and then a horizontal reflection. Okay, first example. Perform each operation to the shape. So you want to draw yourself a pentagon, and we're going to do a few things with it. So it might be a little bit hard at first, but we'll get some practice with it. The next few days we're going to be actually doing some more specific transformations with shapes. So this is just kind of an introduction. So if it's difficult at first, I understand. So first thing we're going to do is reflect it over a line. So draw that pentagon and that line. Ignore that dot. That's for later when we have rotation. That will be the center of rotation. So we're just going to reflect that pentagon over the line. Now remember, every point in that image needs to be the same distance from the line of reflection as the original object. So when I reflect this, every point is the same distance from the line of reflection. Now if I'm not exactly there, I'm pretty close. I tried at least. Okay, so that's a reflection. Part B. Now we're going to rotate it 90 degrees clockwise about the point. I think rotation is the toughest one to draw. So what you want to do is you want to take that point and keep it steady and rotate that pentagon 90 degrees. So this is kind of what it looks like. I like to draw those segments so that I can use those. So I can see I'm going to that horizontal segment at the bottom, and I'm going to turn it so that it is now 90 degrees from where it was. So hopefully you'll be able to see that. When I use PowerPoint, I had to kind of take it off the point, but typically I'd like to keep that end point on the center of rotation and rotate it, but with PowerPoint I could not figure out how to do that. So I had to take it off the point for a bit, but now do you see how that bottom segment is perfectly vertical? So it rotated 90 degrees. Usually if you just take one of those from any point on your shape to the center of rotation, rotate will help you get it over there. Alright, part C, translate it to the right. This is the easiest one. And just shift it over as far as you want. When we do official translations, we'll be shifting them certain units, and we're going to look at that just a little bit in this next example. Okay, example 2. How do the coordinates of the points on a triangle change when you translate the triangle down? So here's a picture of a triangle in the coordinate plane. We've got our vertices. A is the point 0, 1, B is 5, 1, and C is 0, 4. So what I'm going to do is I'm going to make my image, I'm going to change it, make it blue, and then I'm going to shift it down 6 units. So our new coordinates are going to look like this. A prime. We call that A prime. That little, it's like a basically like a little apostrophe, and you say A prime. That denotes the coordinates of the image. So we'll be using that very, very often. So try to remember that. So the coordinates of A prime are 0, negative 5. The coordinates of B prime are 5, negative 5. And the coordinates of C prime, 0, negative 2. So what do you notice about the coordinates? How did they change? That was the original question. How do the coordinates change when you translate the triangle down? So hopefully you notice that the x-coordinate stayed the same, and the y-coordinate, what did it do? Looks to me like it decreased by 6. We went down 6 units, so the y-coordinate decreased by 6. So what do you think would happen if we shifted it up? What about if we shifted it left and right? Think about that. Alright, now we need to talk a little bit about symmetry. You guys are pretty much familiar with symmetry, I think. You've all seen a line of symmetry, and you know that when you draw a line down the middle of something and flip it over, it all matches up. And that's symmetry. But there are actually 3 types of symmetry also that are directly related to our transformations. A figure has symmetry if the figure and its image, so now we're talking about a new image, those two coincide after the transformation. So, for example, with our 3 types of symmetry, we have reflectional symmetry. This is the one you're most familiar with. So if we look at these 4 pictures, those dotted lines are your lines of symmetry. So if you reflect over those lines, just fold it over and everything matches up perfectly, then you have reflectional symmetry. So that square has 3 lines of reflectional symmetry. The S1, if you did a horizontal line, when you folded it over, they wouldn't match up exactly. Blob-looking thing has those 2 lines of reflectional symmetry. So if you fold it over either way, you're going to get the exact same image. But looking at that last picture, no dotted lines there. That's because if I were to draw a line anywhere and fold it over, there's no way I could get anything to match up. So, like I said, you're probably most familiar with reflectional symmetry. The next type is rotational. And that means when you rotate the object, it still looks pretty much the same. Actually, it's going to look exactly the same if you rotate it a certain amount, depending on the object. So let's look at these 3. First is the King of Hearts. So I have to rotate that. If I rotate it 180 degrees, it's going to look exactly like it did before. So that has rotational symmetry. It does not have reflectional symmetry. We cannot draw a line anywhere and fold it over and match it up. The next one is the Ferris wheel. That has rotational symmetry if you rotate it maybe 20 degrees. Maybe. The third picture, bicycle. The wheels on it, yes, have rotational symmetry. The whole bicycle, no. Rotate it, I'm not going to get the same thing. But if I rotate the wheels or the pedals, then I'll have rotational symmetry. And finally, the dartboard. It's pretty much just like the Ferris wheel. Take out the numbers, and if you rotate it either direction, that might be 10, 15 degrees, then you're going to get the same image. So a dart has rotational symmetry. The last one is translational symmetry. So here's a couple examples. Brick wall. Those bricks, you move over, there's another brick exactly like it. Oh, so the color and maybe some defects there, but you get the idea. Then the next picture, that green quadrilateral, slide it over, there's another one. Slide it over, there's another one, another one, another one, another one. Or slide it down and over. See? Translational symmetry. Okay, third example, and the last one. This might be a little tough. Just give a little sketch of the pictures, or even write a description of the pictures if you think that you can draw them. That might be a little bit difficult. So, describe each object's symmetry. First one is just a round table. What kind of symmetry do you think that table has? I think it has reflectional symmetry and it has rotational symmetry. Next one, that's a picket fence. It's kind of old, but it has translational symmetry and reflectional symmetry. Okay, that's your notes for today. So now you actually have some time to relax and read the cartoon. This is a good one. Go ahead and write your out and your summary in your notes, and then when you come to class next time, what we'll do is, well, it's a homework check day, so we'll have our homework and notebook check. You'll have a warm-up to go in these notes. Then I'll give you your homework and you'll have most of the period to work on this homework. Then we'll actually go over the homework in class that day. Hopefully we can get it done so then you can start the new lesson for homework the next night. So make sure that you understand everything. If you need to go back and rewind, look at any part again, make sure you get all the notes, and you can even print the notes if you want. Bring them to class. Might be a good idea. And I will see you next time. Hope you enjoyed. Thanks.